Hello everyone, I'm Benjamin Williams, and today we're doing another lab within Boson NetSim. We're still within the infrastructure section within Boson, and today's lab is going to be on Gateway Load Balancing Protocol number 1, or GLBP. As we know, GLBP is a Cisco proprietary first hop redundancy routing protocol. So let's go ahead and get into our lab objectives for this lab. It says, in this lab, you will configure and verify basic gateway load balancing protocol, GLBP environment. GLBP is a first hop redundancy protocol, FHRP, that will be used to ensure the immediate and transparent recovery for first hop failures and network edge devices by providing gateway redundancy for IP networks. So here's the lab topology that we're working with today. We have an ISP router up here at the top. We have 3 routers. We have R1, R2, and R3. These will be the routers that we will be configuring GLBP on. And then we have our access layer switch. And then we have 3 PCs down here. As you can see, the access layer switch gives our end devices or our end PCs access to the network. And they connect up to all of the 3 routers that GLBP will be configured on. Okay, as we know, GLBP is able to load balance traffic. So basically, PC1 will be using R1, PC2 will use R2, and PC3 will use R3. So that just gives our network some load balancing. Okay, so I've already read through all of the commands and also the descriptions for this lab. So this is always good information to have and also review, as well as I've reviewed the IP address information. And this is also good information to have just so we can make sure that all of the interfaces on each device has the proper IP address scheme and also subnet mask, okay? So let's go ahead and get into our lab task. We will be doing all of our configuration down here at the bottom. We're going to keep our lab topology up here at the top left. We're going to be doing all of our lab readings in the top right, okay? So let's go ahead and get into our lab task. It says task number 1. Configure GLBP. It says, in this task, you will configure Gateway Load Balancing Protocol Group 10. R1 should be the active virtual gateway. So this router is going to be in charge of assigning all of the load balancing for our groups, okay? It says you will also configure GLBP load balancing to ensure that data from hosts is load balanced across GLBP routers in a round-robin fashion. So round-robin, as we know, is an algorithm that just basically chooses one router for one, and then the next router for the next choice, and then the last router for the last choice, and then it's going to go back around. So it's going to go in sequential order. So it's going to go R1, R2, R3, and then it's going to go R1, R2, R3 again, and then continuously continue to do that. That's what round robin does, okay? So number 1, it says on R1's Ethernet 03 interface, configure GLBP group 10 with a priority of 110. Okay, so let's go to R1. All right. let's give an enable to go into privilege exec. Let's give a configure terminal, go into global config. And we want to go into interface Ethernet 03. Sorry about that. All right, and then we want to do a GLBP, a group number 10, and we want to give it a priority, oops, having a hard time typing today, priority of 110. All right, that looks good. All right, now it says on R1's Ethernet 03 interface, enable AVG, or active virtual gateway preemption for GLBP group 10. So, okay, so let's do GLBP 10, and let's do preempt. Okay, all right, now it says on R1's Ethernet 03 interface, configure GLBP group 10 with a virtual IP address of 10.10.25 or 10.10.10.25, sorry about that, and start the GLBP process. Okay, so let's do GLBP 10 IP of 10.10.10.25. Say enter. That looks good. All right, now it says on R2's Ethernet 03 interface, configure GLBP group 10 with a virtual IP address of 10.10.25 and start the GLBP process. Okay, as we can see right here, we see that Ethernet 03 group 10 has transitioned into the active state. Okay, so that's good. and it should be the active virtual gateway as well, but we didn't get that output. But we should have seen the active virtual gateway change as well, but we only see the active virtual forwarder change. Not sure why we didn't receive that output, but that's all good. So go to R2, let's do an enable, let's do a configure terminal, and let's go into interface Ethernet 03, and let's do a GLBP 10, IP of 10.10.10.25. All right, let's give it a second. And it says, what difference do you notice about the debug output when compared with the output of R1? Okay, so let's give it a second. We should see, okay, so we can see that the forwarder for R2 has now transitioned into the active state. But it should have been a difference between these two outputs. But this output on R1 didn't show the active virtual gateway output like it was supposed to. I guarantee you if we click this, it's supposed to say, yeah. So we're supposed to get this output as well. It says, once the process is activated, you should notice a debug message on the console of R2 indicating that R2 has become the active virtual forwarder for GLBP Group 10. The message indicates that R2 is the virtual forwarder, active state for the second forwarder L2 in the group, which is R2 itself. A virtual forwarder can have one of four states: disabled, initial, listen, or active. Okay, so that's the difference that it wanted us to see. It's the active virtual forwarder number 2, and R1 it says active virtual forwarder for number 1 right here. So we can see the difference. It says 2 right here and 1 right here. Okay, all right. So it says on R2, display a brief summary of GLBP configuration. What is R2's virtual gateway status? Well, it should be the backup. It shouldn't be the active virtual gateway. So let's do a do show GLBP. And as you can see, it's in the standby mode. I said backup, but that's what I meant. It's in the standby mode. And if we do the same thing, it says right here, on R1, display a brief summary of GLBP configuration. What is R1's virtual gateway state? Its virtual gateway should be active. So let's do a do show GLBP. And as you can see, its state is active, okay? So that looks good. It says on R2, display detailed information about GLBP configuration. What is the state of AVG preemption for GLBP Group 10? Well, if we go back over to R2, we take a look. We can hit enter. We take a look. We can see that preemption is disabled on R2. So it's not enabled on R2. It's disabled. All right. So that's the state of the preemption. And it says on R1, display detailed information about GLBP configuration. What is the state of the AVG preemption for GLBP Group 10? Well, if we take a look at the preemption over here, you can see that the preemption is enabled on R1, and we did that earlier in our configuration right here. We said GLBP 10 preempt. Okay, so we can see that its preemption is enabled. All right, so it says on R3 interface, 03 interface, enabled AVG preemption for GLBP Group 10. So let's go to R3. All right, let's do an enable. Let's do a configure terminal. Let's go into interface Ethernet 03. And let's do a GLBP 10, a preempt first. That's what it wants us to do. Hit enter there. That looks good. All right, step 10, it says on R3's Ethernet 03 interface, configure GLBP Group 10 with a virtual IP address of 10.10.10.25 and start the GLBP process. So let's do GLBP 10 IP of 10.10.10.10.25. All right, it looks good. And it says on R3, display detailed information about GLBP configuration. Why has R3 not assumed the AVG role? Okay, so if we do a do show GLBP, we can see that its role is in the standby mode. Okay, it's in the standby mode, and the reason that it hasn't assumed the active role is because R1 is currently the active AVG, and it has a higher priority. As we can see, this priority on R3 is only configured to 100, but if we go over to R1, its priority is configured for 110. So it has, R1 has a higher priority, so R3 will not take over as the AVG, okay, the active virtual gateway, okay? So it says on R3, examine the detailed information about GLBP configuration. Why is R2 no longer in the standby role? So if we take a look, we can see that R3 is now in the standby mode, okay? And it is in the standby mode because R2 is no longer in the standby mode because we enabled preemption on R3, okay? We did that first. That was the first thing that we configured right here. So that's why R3 is now in the standby mode instead of R2, okay? So it says on PC1, PC2, and PC3, configure each host to use the GLBP Group 10 virtual IP address as the default gateway. So we got PC1 up right there. Let's bring up PC2 and PC3. Okay, so now we have all three PCs up. And let's do a, I don't know, was my thing off the whole time? I don't know if you guys were able to see my configurations this whole time. Let me pause the video and make sure you guys were able to see the CLI output. All right, so we're back. I'm sorry about the first half of the video. Some of it was cut off, but you guys, it wasn't too much cut off. I rewatched the video. You can still see what the output was supposed to say, but some of the words were cut off. So let's go ahead and resume on question number 13. It says on PC1, PC2, and PC3, configure each host to use the GLBP Group 10 virtual IP address as a default gateway. All right, so if we do an IP config / default gateway, we can do the IP address of 10.10.10.25. All right, that changes the default gateway on PC1. Do the same thing on each of the other PCs. IP config / default gateway 10.10.10.25. All right, lastly on PC3, let's do an IP config / default gateway of 10.10.10.25. Hit enter there. Looks good. All right, it says on PC1 and PC2, trace route the path to 203.0.113.56. What do you notice about the path that traffic from PC1 takes through the distribution layer in contrast to the traffic from PC2? All right, so let's look at the IP address of 203.0.113.156. Let's go to our IP address table. And as we can see, that is the loopback 0 interface on our ISP router. So if we look, that's basically saying we made it to the internet. Okay, so this is our ISP router. It has a loopback 0 interface configured on it. So we're going to ping that. We're going to trace route to that IP address. Let's do a trace RT to 203.0.113.56. And as you can see, it's using R1's IP address. PC1 is using R1's IP address as the first hop. And since we're using round robin, PC2 should use R2. So let's do that now. Let's do a trace RT to 203.0.113.56. Yep, and as we can see, PC2 is using R2, which is 10.10.10.2. Let's go back to our IP address information and confirm. So we can see that PC2's IP address is 10.10.10.2, and R2's IP address is 10.10.10.2, and R1's IP address is 10.10.10.1. And that is the first hop that PC1 is using to get to the ISP loopback interface, okay? So we're using the round robin algorithm, okay? And if we did the same thing on PC3, it would use R3, okay? So it says task 2, verify GLBP failover. It says you have configured GLBP Group 10 on 3 routers. In this task, you will test the active virtual gateway failover and active virtual forwarder failover by simulating a failure on R1, okay? So it says on R1 and R2 and okay, sorry about that. Let's restart. On R1s, R2s, and R3s Fast Ethernet 03 interfaces, disable GLBP load balancing for group 10. Okay, so let's go to each router and do that. So let me move this out of the way, my speaker out of the way, so you guys can get a better output view. All right, so we're already within interface. When we're already in interface Ethernet 03, so we just need to do a GLBP 10. Well, let's do a no GLBP 10, and let's do no load balancing. Okay, no load balancing. Hit enter. Do the same thing on R2. Let's do a no GLBP 10 load balancing. Let's finally do the same thing on R3. Let's do a no GLBP 10 load balancing. Okay. It says on R3 routers, verify that load balancing has been disabled. Let's go to R1 first. Let's do a do show GLBP. And as we can see right here, it says, where's it at? Where's it at? Where's it at? It says right here, load balancing disabled. Let's do the same thing on R2. Let's do a do show GLBP GP. You can see right here it says load balancing disabled on R2. Do the same thing on R3. Let's do a do show GLBP. And as we can see right here, it says this load balancing is disabled. Okay, so it says from each PC, trace the path to the ISP, which is 203.0.113.56. Which distribution layer device is forwarding the traffic for each PC? Okay, so since we just disabled load balancing, R1 is going to forward all of the traffic now. Since we're not using that round robin, to load balance the traffic. We just disable load balancing. So we trace route. You can see that we're using R1's IP address. Do the same thing from PC2. It's using R1's IP address now as well. When we had round robin configured, PC2 used R2. But now since we disabled load balancing, it's using R1. All right. And let's do the same thing on PC3. It's going to be using R1 as well. Let's do a trace RT to 203.0.113.56. And it's using R1 as well. Okay. So it says right here on R1, shut down the Ethernet 03 interface. To what state does the AVG transition? So it should transition to the initial state. I believe that's the state that it's going to transition to. Let's confirm that though. Let's do a no shut. We're already within the let's do a shut. I'm sorry, I said no shut. Let's do a shut. Yep. And as we can see, it is transitioned to the down state. Let's see what state the AVG is in now. Let's do a do show. Okay, let me click down here. Let's do a do show GLBP. And let's take a look. Yeah, so I said the I'm not sure what state I said, but we're in the init state right now. So that's the state that it transitioned to, the init state, since we shut down the Ethernet 03 interface. Okay, so it says examine the console output on both R2 and R3. Which device is now the AVG? Which device is the active virtual forwarder for R1's virtual media access control address? So R3 should have took over as the AVG because we enabled preemption on it. Let's take a look. Okay. Let's do a do show GLBP. Yep, so we can see that it is the active virtual gateway. It's the active virtual gateway. And let's see which one is the active virtual forwarder for R1. Yep. And also R3 is the active virtual forwarder for R1's AVF. It says state is active right here. It says there are 3 forwarders and there's 2 active. So it's active for R1's. It's in the listening state for R2. And it's active for its active virtual forwarder address as well right here. Okay. So it says on R3, display a brief summary of GLBP configuration for which virtual MAC addresses R3 the virtual forwarder for. And we just confirmed that it's the virtual forwarder for R1 and it's the virtual forwarder for itself. And we can do a do show, who wants us to do the brief? Let's do a do show GLBP brief. And we can confirm that right here as well. You can see that it's the active router for R1's IP address, and it's the active virtual forwarder for its MAC address as well. This is the MAC address right here for R1. Okay, so it says right here, it says on R1 display detailed information about GLBP configuration and what state is R1's virtual gateway and virtual forwarder. So they both should be in the init states. As we see right here, it says that the state is in the init state. So if we do it says detailed information. Let's do a do show GLBP. Okay, and as we can see, for the virtual, the AVG, the active virtual router, active virtual gateway is in the init state, and for the active virtual forwarder, it's also in the init state. Okay, so it says from PC1 and PC2, trace route to the ISP, which is 203.0.113.56. What path does each PC take to the ISP now? Okay, so they should take R3. All of the PCs are now going to use R3. So if we look, we can see PC1 used R3's IP address. And if we do the same thing on PC2, which it's asking us to do, it also uses PC3's IP address. Okay, so it says on R1, re-enable the Fast Ethernet 03 interface. Does R1 reclaim the AVG role? Which router claims the standby role? Well, if we re-enable this interface, R1 will reclaim its AVG role and R3 will go back to the standby mode. Okay, so let's go ahead and confirm that it's going to do that. Let's go to R1 and let's do a no shut, bring it back up and let the network converge. Let's give it a second. And as we can see, it is now transitioned back to the active state for its active virtual forwarder. And if we do a do show GLBP, we can see that it is now the active virtual gateway as well for its AVG. So it's now the AVG again. It retook its role because it has a high priority and preemption is enabled. And also it took back over as the active virtual forwarder for its MAC address right here. Okay. All right. And let's see what the standby router is. We can do a do show GLBP brief. And we can see that the standby router is 10.10.10.3, and that is R3's IP address. Okay. So if we do a do show GLBP, we can see that it is the standby now. Okay. So it says from PC1 and PC2, trace route to the ISP 203.0.113.56. What path does each PC take to the ISP now? So they should both use R1's IP address. Let's confirm that. So now it's using R1's IP address again. Let's do the same thing on PC2. And it's also using R1's IP address. Perfect. So step 11 says on R1, re-enable the default method of GLBP load balancing. So let's go to R1 and let's re-enable load balance. So let's do a GLBP 10 load balancing, and enter. All right. So that looks to be the end of this lab right here. So hopefully we did everything correct. Let's hit grade. And we did. So thank you guys for watching this one. And I'm sorry about the beginning of the video. I hope too much of the output was not out of the way. But thank you guys for watching this one, and I'll see you in the next one.